All right, lesson 5. Lesson 5 is going to be on tangents. We are just dealing with tangents. Okay? So, that screen seems like it's getting darker every single day. All right, so anyway, with the tangents, you'll be able to use the properties to solve them, and then you're also going to use those to include circumscribed polygons. That doesn't make a lot of sense right now, but a circumscribed line is a line that's on the outside of the circle. Okay, inscribed is on the inside, circumscribed is on the outside. Okay? So that is what that line means. And again, I apologize because I think I've mispronounced it like a lot of times so far.
It's okay. So those are going.
Yep. So anyway, tangent line. A tangent line is going to be a line that intersects the circle in exactly one point. And they call that the point of tangency. So if I have a circle that looks kind of like this, and a line that cuts across, it's only going to cross that circle at exactly one point. Okay, I'll talk about some other rules that go along with it, but that's what a tangent line is. And this is going to be a circumscribed line. Questions on the first part? All right. I'm skipping some things. Don't worry about these. So here is kind of the rule that goes along with those tangent lines. When you have a tangent line, from the radius to that line, they are going to be 90-degree angles. It's going to be perpendicular to each other. Guaranteed. Good. All right, so looking at this one, I'm going to start off with my very first triangle here. If that circumscribed line and the radius come together at a 90-degree angle, together they should make a right triangle, right? So if we want to test to see if the triangle is a right triangle, what we do is we just set them up using the Pythagorean theorem to figure out if they actually are perpendicular to each other, or if it actually is going to be a right triangle. So if we want to determine if it is a right triangle, we'll use Pythagorean's theorem to say that 8 squared plus 6 squared equals 12 squared. We're going to do this to see if these match up. So if the stuff that's on this side of the equal sign and this side of the equal sign are equal, then it'll be tangent. If they don't equal, it's not tangent. So I've got 8 squared is going to be 64, plus 6 squared is going to be 36, 12 squared is going to be 144. Add them together, 64 plus 36, that gives me 100 equals 144. That's not quite right. It's definitely not right. It's not equal. That never happens. Because 100 is not equal to 144, that one, it's not tangent. Yeah. Again, you'll do the math, you'll see that they're not equal. And your answer will just either be tangent or not tangent. This one, because they're not equal, I'll make a little not equal sign. Those ones are going to be not tangent, or that triangle, that line HG or GH is not tangent to that circle. Making sense? Okay. Did I go too quick?
Yeah. Thank you.
You're welcome. Okay, so I'm going to look at the same triangle down here, or not same triangle, but another problem that looks very, very similar. So again, I have a triangle that the two legs are 20, 21, and the hypotenuse is 29. How would I set it up?
20 squared plus 21 squared plus 20 squared.
Awesome. 20 squared is going to be 400. 21 squared is going to be 441. That sounds right. Yeah. And then 29 squared is going to be 841. Did I do that math right? Yeah. Okay. So put them together, 400 plus 441. That gives me 841. That says equals 841. Is that true? Yeah. If they're true, what's that tell me about that line? It's a right angle, but it's also tangent. I can't spell. Just get the idea. Tangent. Again, these equal each other. That tells me that that line's going to be a tangent line. Thumbs up, thumbs down. How you feeling? Super duper, gang. So on this one, they're going to give us some additional problems. They're going to tell us, for some of them, assume that if the line looks like it's going to be tangent, it is tangent. Okay?
Yeah, that's what I was thinking on the other one, but then ended up being 100.
So yeah, the stuff above it,
It looks so.
yeah, the stuff where they give you all the sides, those ones we don't make the assumption, we just have to solve it. There's going to be some that will give us a variable. If they tell us that we need to solve for a variable, it will give us this little note in the instructions that says, assume that segments that appear tangent are tangent. And I'm going to let you know there's going to be some that almost don't even look like they're tangent, but like they'll go off to the side. You'll see one today. Just based on how they're drawn, they look weird. But we're going to make that assumption. All right, so anybody, how would I set this up to solve for x? Okay, 14 squared. I'm going to stick with you. Keep going. You got this. You got this. I believe in you.
17 squared.
So is 17 squared, is that going to be the hypotenuse or is that a leg? Okay, so I got hypotenuse over here. Here's a leg. Here's a leg. So we got 14 squared. Remember that on the other side is going to be the hypotenuse. That's going to be on the other side of the equal sign. So what's going to come after that 14 squared? X squared. I love it. Just got to be confident. You got this.
Could you say these squares?
What's that?
Yeah, never mind. 17 squared. So young.
Fantastic. You did it.
Okay.
Proud of you. Okay. So I've got 14 squared plus x squared equals 17 squared. Again, as soon as we turn it into like that stuff that we've done from a couple chapters ago, because there's a circle in there, for whatever reason, it seems like it's way more confusing, but it's just Pythagorean's theorem. Okay, so 14 squared, get that again. 14 squared is going to be 196 plus x squared equals 17 squared. 17 squared is a big number. 289. Okay, and then I get to do these ones. I've got 196 plus x squared equals 289, so I'm going to subtract 196 from both sides. So I get x squared equals 93. The very last step is to get that x all by itself. So I'm going to square root both sides. X is going to equal 9.6, roughly. Feeling good?
Do you have to determine its tangent after that?
No, the assumption is that it is going to be tangent.
Oh.
Yeah, so we don't have to figure anything else out from tangent. So that first part was going to be, we had to figure out if it was tangent. These ones, we're saying they are tangent. Guaranteed they're tangent. We have to figure out that other, what the variable equals. Okay? All right. I'm going to give you a tough one here. I'm skipping over the second sample because you'll see one that looks like this. Looks scary. I promise you, I will talk you through it. We'll make it not as scary. But go ahead and try to draw that triangle. All right, then just for clarity's sake, I'm just going to redraw the triangle again. Yeah, I'm just going to redraw it again so you can kind of visually see what's there. If you already drew the triangle, don't worry about it. Okay, so this leg over here was 24, so I got this one. This one was going to be x. However, the hypotenuse has all of this. So to figure out the length of that hypotenuse, if you really kind of want to visually see it, like this would be like x, this would be like that 16. So how do I figure out the full length of that side? Well, even before I get to the Pythagorean, I just add those ones together. So the length of this side, the hypotenuse, is x plus 16. Because it's going to be both of those parts together. Okay? So now I can go through and now I can do the Pythagorean theorem. And bear with me, don't get scared yet. I've got x squared plus 24 squared equals x plus 16, because that was all in there.
Why is it 24?
Because it's this length. I'm doing leg squared plus the other leg squared equals the hypotenuse squared.
Oh, yeah.
Okay, so I've got that x squared is going to stay x squared. So I've got x squared plus 576 equals. Now, when I had this x plus 16, this is all in parentheses. This is going to be kind of your reminder from algebra last year or getting you ready for algebra 2 next year. So remember, x plus 16, if it's squared, is the same as saying this. And you can FOIL that part out. Unless did you guys go over like the quick little shortcut way to get these answers? Without foiling? I'll do the FOIL then. Okay, so let me get a different color pen just to show you. It's okay.
I hate foil.
Foil is we did foil in biology. That's what I hated.
When you're doing like Punnett squares.
Oh, yes.
So you should have had x squared plus 16x plus 16x plus, and then 16 times 16 is another big number. You already did it, 256. So my next line down here, I got x squared plus 576 equals x squared plus 32x plus 256. Okay. Looks scary. Not so bad though, especially if I show you the next step. I'm going to start combining like terms. I got an x squared over here. I've got an x squared over here. I can just subtract it from the other one. So minus x squared, those are both gone. Now I got 576 equals 32x plus 256. Now it's just algebra. I'm going to minus 256 from both sides. Minus 256. I get 320 equals 32x. 32x. Divide both sides by 32. X is going to equal 10. You'll have one like that. Okay. Yes, ma'am.
Why did you cancel both of the x?
So I had a positive x squared on this side and then this side. So to combine like terms, I wanted to move this one from this side to the other side. So I minus the x squared, so minus 1x squared. And 1 minus 1 turns into a 0x squared. And that's why they canceled out.
Okay, yeah.
Feeling okay? Gerard, do you want to sit in the front to see it?
No, I'm good.
Okay. Good? Oh, you got told to shut up. I know that one because my Spanish teacher told me that a lot.
That's telling Ricky.
I know. I got it. I called out Ricky, so you got told to shut up.
What I told her, shut up.
You probably didn't hear it because you're talking.
Oh, really?
Yeah.
Oh. I'm not talking. I'm paying attention.
I don't know a lot of Spanish, but I know the one that they tell me to shut up.
Why would you do that?
There's a kid in my class who's Spanish and he's
I would never tell you to shut up.
All right.
So disrespectful.
So anyway, this this theorem right here. Oops, I drew those parts on already. I'll show it again. So this segment right here, again, same assumption that each one of these lines is going to be tangent. So if I've got the tangent line here and a tangent line here, okay, that means that where they come together, from the radius to that point, it'll be a right triangle, or right angle. Radius to that point, it's going to be a right angle. I now have a kite. The same thing that we did from chapter 4. This is still like first semester. Okay. A kite was this shape. You remember that? I'm getting like a dirty look. But that was, anyway, neither here nor there. Because of that, that's kind of, I'm showing you like the proof portion of it. But because of that, each one of those lengths are going to be the exact same length. Sorry, each one of those sides is going to be the exact same length. So when you have two tangent lines coming together to make one point, each of those line segments is going to be equal to each other. Okay? So my first example looks like this. Again, these ones assume that the tangent line or the lines are tangent. I know it does not look like they're tangent lines. It's the magic of math. We're going to pretend.
Will this stuff be on my room?
Yes. So if you will see one of these on your test, you'll see one of them on the final. So again,
17.
these are both tangent lines to this circle. So if they're both tangent lines, they come together at one point. What can you tell me about those lengths? Perfect. They're the same. So I got 3x plus 2 equals 4x minus 3. Again, they equal to each other. It's just regular algebra at this point. So I got 2 equals x minus 3 plus 3 to both sides. I get 5 equals x. Ta-da. You got one more. Okay. So the very last, anybody have the chance to write that one down? Okay. So the very last thing, I'm not going to worry about all the other circumscribed polygons. But if I have this triangle and it looks kind of like this-ish, pretend I can draw well. Now it kind of makes me want to watch Harry Potter.
Wait a minute.
Right?
You're just trying to draw a line down.
Right? Okay, so anyway, if I have this circle with all these lines that are going to be circumscribed around the outside, that means that in between, pretend again, those ones come together, that these ones are both going to be the same length as each other. Because again, I just have those two circumscribed lines that come together in one point. Over here, I've got two circumscribed lines that come together to make one point. So over here, these ones are going to be the same length. On this opposite side, these ones will be the exact same length.
Would the 3 lines and the 2 lines would go with each other?
No, not necessarily. Sometimes they could, but not necessarily. Because again, I could make a terrible looking circle that so again, these ones can be super short, like a middle size. Okay, make sense? So the very last one we're gonna do, not that one. It works with all the other shapes. I'm just doing one with a triangle because it only has 3 sets instead of having to do like 4 or 5. Okay, I've got this shape here. What it wants us to do is define the perimeter of the entire thing. So if you want to draw that down, I'll give you about 30 seconds or so. You can draw it and then we'll talk it.
Draw that down.
All right, so again, I'm going to put some points on here just to kind of visually show it, just to show where that tangent line is going to be at. So with this part over here, I'm going to start here. If this length is going to be 10, what's the length of SN? That's going to be 10. Okay, if NQ right here is 2, what's QL going to be? It's going to be 2. So again, this line segment here and this line segment here. So that'll be 2. Okay, we got to do a little bit of math to figure it out. But how long is LR going to be? How'd you get 6? 8 minus 2. Because it gives you the full length. That means that this length is going to be 6. So how long would MR be? Also 6. So to figure out the perimeter, before you can add every single one of those together, I'm going to combine a couple of those numbers just so I only have to add 3 of them. So between S and Q, that's going to be 12. Between S and R, I'm going to add that 10 plus the 6, that's 16. So to get that full perimeter, I'm going to have the 12 plus the 16 plus the 8, which tells me the perimeter of that whole entire triangle is going to be 36. Make sense on how we got there? That's it. Page 736, 13 through 21 odd. Everyone is odd, so if you get confused, you can double check in the back of the book. And then number 24. Number 24 is going to be that triangle one that we just did. Well, not the exact same one.